Number 20. What is the gravitational potential energy of a 450 kilogram car at the top of a 25-meter parking garage? We need to remember that our gravitational potential energy equation is equal to the mass times gravity times the height. In the equation, they give us our mass and they give us our height, and we know that our g is always 9.8 meters per second squared on Earth. So we have the information to plug into our equation, and we would get 450 kilograms times 9.8 meters per second squared times 25 meters to give us a gravitational potential energy of 110,250 joules. Number 21. What is the change in gravitational potential energy of a 45 kilogram weight that is moved from a 2 meter to 18 meters on Earth? What is it on the moon? 1.6 meters per second squared. So here we're again going to be using our gravitational potential energy equals mgh. Here, since we're talking about being on the moon, our g is going to equal 1.6 meters per second squared rather than 9.8. They give us our mass, and we need to subtract to get our height. They go from 2 meters to 16 meters. So our height is going to be a change of 16 meters. 2 meters to 18 meters, so it's a 16-meter change. So using our 45 kilograms, our 1.6 meters per second squared, and our 16 meters, we can multiply all of those quantities together to get our answer. So again, we have 45 kilograms times 1.6 meters per second squared times 16 meters, and we get a gravitational potential energy of 1,152 joules. Number 22. A 0.25 kilogram book falls off a 2-meter shelf onto a 0.5 meter chair. What was the change in GPE? Again, our GPE is going to equal mgh. And we know that our g is going to be 9.8 meters per second squared on Earth. And they give us our mass. And our height, again, we have to calculate. We have to do a subtraction. So we have to subtract our 2 meters from 0.5 meters, so we end up with 1.5 meters as our height. So then if we plug in, we have 0.25 kilograms times 9.8 meters per second squared times 1.5 meters. We will end up with a GPE of 3.675 joules. Number 23. A 60 kilogram girl falls off a waterfall and loses 10 kilojoules of GPE. What was her height? So first we're going to have to take our equation and manipulate to solve for h. So we usually have mgh. We need to solve for h, so we're going to divide by mg on both sides. And when we do that, we will have h equals our GPE divided by mg. They tell us that our GPE is 10 kilojoules. Remember, that's going to be 10 times 10 to the third. And they tell us our mass is 60 kilograms, and we know again that our g is going to be 9.8. So if we plug in, we have 10 times 10 to the third joules divided by 60 kilograms multiplied by 9.8 meters per second squared. So when we do that calculation, we find out that our height was 17 meters. And lastly, number 24. When a 0.5 kilogram rock is dropped from a height of 12 meters on planet Z, it loses 45 joules of GPE. What is the acceleration due to gravity on planet Z? So here they are looking for our G term. So if we have GPE equals mgh, they are looking for what G, or gravity, is on this planet Z. So to find that, we need to divide by mh on both sides, and if we divide by our mass and our height, we can solve for G. So we will have G equaling our GPE divided by mh. We have our GPE of 45 joules, we have our height of 12 meters, and we have our mass of 0.5 kilograms. So we're able to plug in. So we have 45 joules divided by 0.5 kilograms times 12 meters. And when we do this calculation, we find out that our G is equal to 7.5 meters per second squared.